This is the lesson for 8-1, day 2. What we're talking about today mostly is box and whisker plots and then something called skew. Down below here is an example of a box and whisker plot. A box and whisker plot, why they call it a box is because you have this box every time right in the middle. And then you have these two things going off of it, which sort of look like whiskers, all right? What a box and whisker plot is it's just a different way to sort of illustrate or put a picture to your data. So if you think back to the previous lesson, we were talking about the amount of sugar in one serving of cereal. So here's all these numbers again, all right? And what they did is they took these numbers and they made a box and whisker plot out of the numbers. So what do these things mean on a box and whisker plot? Well, your lowest number is right here, all right? This is your minimum number, all right? It's your lowest number. So our lowest number is 1. Our highest number is at the other end of our whisker, all right? That's how far the box and whisker goes. This is your max, your maximum number. So your lowest number is here, your biggest number is here. And if we take a look at our data, we can see that 1 is the lowest number and 22 is our highest number. So that's where we're getting those from. The other three things on the box and whisker plot, this number right here in the middle, this is something called the median. The median is the middle number in the data. All right, the median is the middle number. And I'll show you how to calculate the median in a second, but just know that this is the middle number. So our median is 7. Notice how this line lines up right above the 7. Then we have the two edges of our box. So we have roughly about 4.5, and we have roughly about 10.5. So this is your Q1, and this is our Q3. What those really mean are quartile, all right? It's your first quartile and your third quartile. What those are is those are the median of the bottom half set of data and the median of the top half set of data. So when we take a look at this, 25% of your data is in between the minimum number and quartile 1. 25% of your data is in between these two things. The next 25% of your data is in between quartile 1 and the median, which is the middle number. 25% of your data is in between the median and quartile 3. And then the other 25% of your data is in between quartile 3 and your maximum number. So the box and whisker plot sort of separates it out into 4 sections. You have the 25% right here, 25% here, 25%, and 25%. You need to know all of this information and this picture, all right? The minimum number is this edge of the whisker. The edge of the front of the box is where quartile 1 is. The middle number, the median, is this line inside the box. Your quartile 3 is the edge of this box, and then your maximum is here. So half of your data is below the median, half of your data is above the median. Now, could you figure this out by hand? Sure. If you wanted to figure this out by hand, the first thing that you'd have to do is put the numbers in order from least to greatest. So you have all of these numbers. We would have to put them in order from least to greatest. If we go, I'm just going to save a little bit of time. I already have these numbers in order from least to greatest. Then we have to do something called the 5-number summary. All right, that's an important vocabulary word. The 5-number summary represents the 5 things on your box and whisker plot: the minimum, your first quartile, the median, the third quartile, and your maximum. So I like to start off with the min and the max first. The minimum is your lowest number. So our minimum here is 1 because 1 is our smallest number. The maximum is our highest number. Our highest number here is our last number when we put it in order from least to greatest. So that would be 22. Now we need to find the median. Now the median is the middle number out of all of our data. So we need to figure out how many numbers we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So our middle number in our data, we would cross one out from the beginning, cross one out from the end, cross one out from the beginning, cross one out from the end, cross one out from the beginning, cross one out from the end, beginning, end, beginning, end, beginning, end. We're working our way towards that middle number. And we end up with 2 numbers in the middle. So our middle number would be halfway in between these. Now, these two happen to be the same. So we have a 7 and a 7. So our middle number is 7. We would take the average of those 2 numbers. So we would have to add them together. 7 plus 7 is 14. And then take 14 and divide by 2 to get 7. Sometimes you're just going to end up with 1 number left over when you take away 1 from the beginning and the end. And that 1 number, when we have an odd number of numbers, it would just be that single number. But if you end up with 2 middle numbers, you have to take the average of those 2 numbers. So add them together and then divide by 2. So this is where the middle of our data would be. Now, what the first quartile and what the third quartile, this is the median. I'm going to switch colors here. This is the median or the middle number of the lower half set of numbers. And the third quartile is the median of the upper half. Set of numbers. So let's take a look at the median of the lower half. So we're only looking at these numbers, our lower half set of numbers. So again, what you would have to do is you would have to cross out from the top and from the bottom, the first and the last, the first and the last, the first and the last. We end up with 2 numbers right in the middle. We have a 4 and a 5. So 4 plus 5. 4 plus 5 is 9. 9 divided by 2 is 4.5. We want that number that's right in between. Now, sometimes like these, it's easy to calculate that. All right, what number is exactly halfway in between 4 and 5? It's 4.5. All right, so our first quartile number, the median of the lower half would be 4.5. We're going to do the same thing for the median of the upper half. Cross off your first and your last, your first and your last. We're working our way towards the middle. For this one, we end up with 2 numbers in the middle, 10 and 11. Again, what number is halfway in between 10 and 11? Well, halfway in between 10 and 11 would be 10.5. Or you could find the mean or the average of that. So this would be 21 when we add them together and divide by 2. And that gives you 10.5. That is the, this is the median. Sorry, I went on the wrong line here. This is the median of the upper half. So that would be 10.5 for your Q3 or third quartile. Now, there is a way to do it on the calculator, which is a lot easier, all right? You never have to calculate these by hand. The calculator will do it for you. So how the calculator does it for you is on the calculator, you're going to go to Stat Edit. All right, so let me go ahead and do that for you here. Let me pull up the calculator. So I need to stop sharing my screen. I need to click on this and this at the same time. So now you should see my calculator and the screen. All right, so what we need to do for this is we need to go to, oh, let me hide this. We need to go to Stat and Edit. So Stat is right here next to the arrow pad, and then Edit. We're going to type in our data into the L1. So we will need to type in our data. We don't have to put them in order, so we could start here and go 13. Whoops. We could start here and type in 13, and then 7, and 4, and 5, and 4, and 5, and 11, and 12, and 7. You're going to have to do this on a lot of questions. 10, and 4, and 10, and 3, and 7, and 4, and 7, and 1, and 8, 22, 6, and 11. Now, notice how it says L1 and then inside parentheses 20. Remember that I counted that there are 20 values there, so I know that I did not miss one. If you screw up even with one number in your list of numbers, it will massively screw up, all right? So what we're going to do to find our 5-number summary is, now that we typed in our data into L1, we're going to go back to Stat. This time we're going to tab over to Calc. Notice how it says 1 VAR statistics. That's really one variable statistics. So that's what we want to hit. So we want to hit enter. And then it says, do we want to use the list in L1? Yes, we do. So we just want to tab down to calculate and hit enter. Then you get all this blah, blah, blah. Now it goes down further. The numbers that you're actually going to want go down further. So you have to arrow pad down, because we want these numbers at the bottom. Now, these numbers match what I have on the screen right here. All right, so I'm going to be done with the calculator. So I'm just going to minimize the calculator and go back to this. Let me just make sure that the screen is full here. So these are the numbers that I got on the calculator. It's very important that you know what these numbers are. And this is probably going to be a slide that you want to go back to, because this number right here, this is your mean. All right. Remember, mean means average. That's going to be a number that you are going to use later on in the chapter. This little X with the little line above it is the symbol for mean in math. This one, the one below it, this is the Greek symbol for sigma. All right. Sigma and then X. This is your values added together. So it took all of the numbers and added them together. All right, so it took all of your values and added them together. Will you ever need that? No, we won't. All right, will we ever need this? No, we won't. That's just squaring that 157. We don't need this number ever. Remember, these calculators are used for a lot of different things. This symbol you'll definitely need later on in the chapter. This is standard deviation. That's actually a section later on in the chapter. All right, this is the standard deviation. Then we have how many there were. All right, we have how many there were. There were 20 values that we typed in. And then we get to these 5 things. This is your 5-number summary. This is where you're going to get your data for your box and whisker plots. This is the min, so that's your lowest number out of your data. Here is quartile 1. This is the median, which is your middle number in the data. This is your quartile 3, and then this is your max number. You need these 5 things from your 5-number summary to make your box and whisker plots. Because remember, this is the edge. Your min is the edge of the whisker. The max is the edge of the whisker. Then you have the 2 sides of your box, and you have that line in the middle of your box. So being asked some questions about this. What percent had at least 7 grams of sugar? At least 7 grams. Now, at least 7 grams, if I go back to my numbers here, and I'm just going to erase right here so we can see these numbers a little bit better. At least 7. At least 7 is 7 or higher. So I'm taking a look at all of these. All right, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 out of the 20 that have at least 7 grams. Now, to make a fraction into a percent, at least 7, we have to do top divided by bottom, move the decimal point over 2 places. So this represents 60%. Now, that's what you could tell from the actual data. If we go back to our box and whisker plot, how many had 7 or more? Well, from our box and whisker plot, you really can't tell the exact amount, all right? Because it looks like from our box and whisker plot, there's only 50% of our data from our box and whisker plot. But in reality, there is 60%. So you can't tell everything from the box and whisker plot all the time. What percent had 3 or fewer grams of sugar? 3 or fewer. 3 or fewer, there are only 2 numbers that are 3 or fewer. All right. We can't tell that from our box and whisker plot because we can't tell how many are 3 or fewer. It's somewhere in this bottom 25%. We can't tell for sure. If we had the data, we would do 2 out of 20. 2 out of 20 is 10%. Remember, top divided by bottom, move the decimal point over 2 places. All right. So the number being asked has to be part of the box and whisker plot. So if we were asked to just look at the box and whisker plot, you could not determine your 3 or few grams of sugar. So now let's take a look at something that is totally different. What we're talking about here is something called skew. All right, these are our dot plots. All right, these are our dot plots from the other day. The overall shape is called the data distribution. The data distribution is the way that the data is spread out or clustered together. The shape of the distribution can reveal a lot about the information of the data, but most common, we're looking for these 3 vocabulary words: symmetric, skewed left, and skewed right. Symmetric, it is essentially almost the same. Does it have to be exactly the same? No, but it's sort of this even hill shape, all right, where we go up and then we go down. Approximately half the data is above and about approximately half the data is below. It's sort of, I could almost draw a line right here down the middle, and it's almost like an even hill. About half of your data is above and about half of your data is below. Those 2 sides match up pretty evenly. Does it have to be exactly perfect? No. All right. It does not have to be exactly perfect. Now, skew right and skew left. Skew right and skew left, there's like data points that are stretching out your data. So skewed right, the bottom of the hill is over to the right. This bottom part is longer than the upper part, all right, because it's being stretched to the right. Skewed left, and we'll see more examples of this, skewed left, the bottom of the hill is being stretched to the left. So notice that the majority of our data here is to the left. The majority of our data here is to the right. That skew is being stretched. So this bottom part, this longer part is over to the right. This longer part is over to the left. We'll see more examples. So this is a slide, again, that you're going to want to look at a lot and refer back to. I actually put one of this slide in your resources folder in your Algebra Schoology page. I also put it in today's notes, all right, in today's folder. So skewed left, these are all examples. These are split right down the middle here in 3 sections. So skewed left. skewed left, the bottom of the hill is over towards the left because though these little outliers here are being stretched and making our data skew to the left. Notice that we only have a couple little points down here. All right, the bottom of our hill is over to the left. One or two data points is making it being stretched to the left. Same thing here. Remember, half of our data is here. Are these two, are the green and the yellow even? No, you have more over to the left. So our data is being skewed to the left. All three of these pictures represent skewed left. Here, these are all skewed right. Notice the bottom of our hill is over to the right. These are all being skewed to the right. Notice that our middle number is right here. So half of our data is all in this area. Are the yellow and the green the same? No, our data is being skewed to the right. Here is an example of symmetric. Symmetric is like that evenness, all right? Does it have to be exactly even? No, but it's pretty darn close, all right? Notice even here we go up and then we go down. Pretty much right here in the middle, it's even. So if I split it right down the middle here, it's pretty close to being even. Does it have to be exactly perfect? No, but you got about half of your data on each side. Same thing with here. Remember, this is the middle. This is our median right here. About half of our data is above and about half of our data is below. Those two reach out or stretch out about the same. All right. So symmetric is about the same on both sides. Skewed left goes over to the left, reaches out, stretches out to the left. Skewed right stretches out or reaches out to the right. Again, this is a page that you're going to want to refer back to. So let's take a look at a couple of these graphs and decide, are they symmetric, skewed left, or skewed right? Well, when we take a look at this one, notice that our hill goes up like this, it goes down, but then it keeps on going because of this 22 here, all right? Would this, I want you to think about it, would this be symmetric? Would it be skewed right or skewed left? So if it didn't include this 22, I would say it would be very symmetric. But because of this section down here, this is being skewed right. All right, this is being skewed right. Let's take a look at another one. Take a look at this one. So this one goes up and then it goes down. This one would be symmetric. Now, is it exactly perfect? No. All right, but is it pretty darn close? Yes. All right. Now, if it had data down in here, then it would be skewed to the right. If it had data like down in here, a whole bunch of data, then it would be skewed to the left. But this is pretty even. This one little thing here doesn't make a difference. All right. How many total people? You're going to be asked questions about these. How many total people is there? Well, what you would have to do to figure out the total people is you would have to add 7 plus 10 plus 18 plus 21 plus 34 plus 23 plus 18 plus 11 plus 4 plus 4. How many total people would there be? There would be 150. Let's take a look at the next two. If you take a look at this one, notice that it goes up and then it goes down. All right. Notice that we have this section of the graph. This section of the graph makes it skewed to the right. All right. This is skewed to the right. How many total would there be? We'd have to count the x's. If we count the x's, there are 20 total x's. And in this one, notice that it goes like this. We have this big long tail here. Because of this section, this would be skewed to the left. All right, This would be skewed to the left. How many total people would there be? Now you have to be careful. Notice that our y-axis here is counting by twos. So this is really 1, this is really 2, this is really 3 people, this is 1, this is 2, this is 4, this is 8, and so on and so forth. If we added all those up, there would be 79 people. So again, let's take a look at our box and whisker plot, because you're going to have to make these today. All right, in our box and whisker plot, again, it should look like this. All right, I'm just going to redraw it down here. We have our max and we have our min. You need to pick out your median, all right, your Q1 and your Q3. Once you pick out your min, your Q1, your median, your Q3, and your max, just put these into a little box and then just make your whiskers coming off that box. That is the box and whisker plot. You have your min, Q1, median, Q3, and your max. Then for skew, remember you want to find those numbers for your box and whisker plot, you need to do the one variable statistics. So stat edit, type your numbers into L1, and then do stat calc, one variable statistics, and calculate. This is your 5-number summary right here. That will give you your 5 data points for your box and whisker plot. Then you have your symmetric. Symmetric is like almost the same on both sides. Skewed to the right, it keeps on going on and on to the right. Skewed to the left, it keeps on going on and on to the left.